So what I'm going to talk about today are virtualized deployments and why. Why, the point here is why. When I'm done with this, I'm hoping that I get the message across of why this is important. Not necessarily the technicalities of how and all that detail, but why is this flexibility key to future media workflows? So this really stems from our vision. This is what our vision is at the Telos Alliance. That we see the future as the broadcast facility being implemented using modern server software technology. So why do we follow the IT industry? If you remember, more than 20 years ago, we innovated the use of audio over IP. And the key to that was being able to use the standard Cisco switch, the standard IT technology switch. Well, to understand, we're not blindly following the IT industry, so we can look at why the IT technologies developed in the way they did, and then we can understand why they're so important for us. So we're going to look at that. We're going to look at what are the modern IT solution technologies. And of course, then our job, we feel, is to be the expert link, bringing the IT technologies to broadcast. So why did the IT industry involve virtualized software? And these are the key things to understand. And they're really fundamental. I'm not speaking any great magic here, but it really stems from the same problems we've always had. Hardware is unreliable. And as they went and started to build thousands upon thousands of services and servers, this got to be a big problem. So they had to solve it. Again, very basic, very fundamental. Human labor is expensive. If you have thousands of computers, you can't have teams of hundreds of people the way that they used to do in the first computers with the ladies who would go and replace the vacuum tubes in the ENIAC. You can't afford to do that. A final economic thing is when you have so much to produce and so much equipment, are you going to have spares for thousands of devices? So when you start using virtualized software, you are enabling the fact of using standardized servers. And I've made this statement before. The special thing about servers is that they're not special. They're very generic. They're swappable. You are using from a pool of resources, which allows you to get the economics of not having lots of different spares. Now, here's the key thing. All of those reasons I just listed from the IT industry, we in broadcast have exactly those same needs and more. So this is the driving reason to pay attention to how they do their technology, how can we borrow it, how can we use it, because we need the same things they do. So the server-based virtualized software solves those problems, solves these problems. It's not a buzzword, the cloud. It's not just the latest thing. They're solving very real problems. So I've already touched on some of these. So you have the on-the-fly automated, and that's a really key word, automated replacement of failures from a pool of identical, and that's another key word, identical resources, identical servers. It is getting away from racks and racks and racks of equipment that each piece of equipment does exactly one thing, and needing a human being to go and throw a switch or swap out that rack when something goes wrong. The fact that the virtualized software allows you to automate your operations with less labor. You can shorten the fault response time. Now, I'll touch on this a little bit later. How do you define fault response time? But in the middle, I always use this, I always ask this question: who is the broadcast engineer? And I answer that question by, who is the guy or girl, gal, who has to get up in the middle of the night when you go off air, right? Who's the person that when there's dead air, they jump 3 feet? That's the broadcast engineer. Well, These solutions with virtualized software enable automated recovery so that the system can be recovered often before anybody notices in the middle of the night. That's really important. Virtualized software enables the orchestration. This word gets thrown around a lot, but what orchestration means is software controlling software. And that can sound like a scary thing, but it means you have automated systems, software that's running, that's making sure that your servers, your programs, your containers are all running the way that they should. I already mentioned the streamlined spares. You have standardized spares. In fact, one of the ways you get the high availability is those spares are turned on and running. They're just not busy right now. The orchestration software gives them work to do when they need to. And then improved operational efficiency in your operations, configuration, maintenance, monitoring. All of these things are not possible with hardware boxes. So this is why the IT industry evolved for virtualized software, to be able to do all these things. In fact, so for broadcast, my point is, the more mission critical the function is, like our air chain, the more you need all this stuff. Some people say, oh, I can't trust my live program to the cloud, or I can't trust it to software. But guess what? This is the best technology for keeping that stuff running. So we can't afford not to do it. And again, stressing that this isn't just the buzzword. Sometimes people say the flexibility is because you can run it anywhere. That's not really the point. That is a side benefit, but that's not the main point. So what do I mean? What is virtualized software, and how is it deployed? So it's just a little bit looking at some of the terminology, some of the methods. So there's two main methods. You either use VMs, virtualized machines, and hypervisors, or you use containerized software, of which Docker is one of the names. And I want to be clear that Docker doesn't mean you have to use Docker. There's a standard behind it called OCI compliant containers and OCI compliant hosts. So what is this Docker thing? I think most people might be more familiar with virtual machines, VMware, the fact that you can have a server and you can run multiple virtualized machines. Think about what's in that virtual machine, and that helps you differentiate what's different with Docker. So a virtual machine is like a machine in a rack. It's got CPU and memory and storage and hard drives and its whole operating system and all of its I/O drivers. So all those operating systems need the operating system security updates. Everything that's in that virtual machine, and it could be too much. It could be too much stuff, especially to automate. I mean, everybody's had the experience of your operating system decides, like a lot of people run virtual machines in Windows. Windows will decide, to do an update. A human being may have to interact with that. So the folks who invented containerized software thought through all this, and they said, what actually is the piece that we need to virtualize to allow us to run the software that we want to and take care of all of the dependencies. Anybody who's ever installed software in a machine knows that if you don't have the right set of libraries, maybe the thing's not going to run right. If you try to install two different applications that need different libraries, you're stuck. All of those problems are what they solved with containerized software. Furthermore, it's portable because of the OCI standard. It can be very quick, and it can be automated. So this is the orchestration, software running software, automated, less labor. So what's going on inside of Docker with containerized software? Well, I already touched on this. You have all of the dependencies that you need inside that container, so you do not have to update the drivers and the libraries on the host system. These pieces that you need to run your product, your container, are less than the whole operating system. So it eliminates that overhead of maintaining whole operating systems everywhere. Furthermore, different containers have their own dependencies in them, so you can run multiple containers on the same host machine and you don't have this problem of conflicts. So why is Docker so prevalent? Well, it's designed for whole facilities, like when you have you're designing a broadcast facility. Docker is Linux server software. It can be run on your machine, on premises, or you can run it in a third-party server. You can run it in the cloud, AWS, Google, for example, Azure. As many containers as you want to run, you can spin up so it can scale on demand, and this is how major websites work. If you still want to use virtual machines, and many customers do, and that's perfectly fine, you can run the Docker host inside of the virtual machine. Now, one thing to note here, this is a technology that has its own complexity and special expertise setting up, and this is where the folks that we often call DevOps and infrastructure as code, those are kind of a couple of the buzzwords that you get involved with. But this is the way that the IT industry works. So these folks aren't rare. Finding a good person can be just as valuable as any other member of your team. So how does the virtualization and how do the containers help you stay on the air? How does it help redundancy? Well, fundamentally, and again, this is just a simplification, but it's really important to understand why this stuff is important. Redundancy for us in broadcast means keeping the product function running. So this is what it does. So the general strategy is very basic. If something stops, if a server dies, remember, hardware breaks, then you start up whatever it is. You knew what was running on that server that stopped. You started up on available pool of other server resources. Containers are designed to make those functions as quick and easy as possible. That's a lot harder if you're dealing with full virtual machines. And if anything is left to needing human intervention to go set up like VMware, then it's not automated. So Kubernetes is one of the orchestration software systems that's often used. And that's a name that usually gets thrown around to find out if you know something about this world or not. So if you say Kubernetes and the person doesn't give you a blank stare, you know you're talking about the same kind of things. So this is going back and touching on the economics again relating to the why. There's a lot of technology here, but what drives this is the economics. So there's two important things. You have the uniform servers, and you have this very flexible networking. And that gives you the economics of saving labor, where because you've automated your facility and you have orchestration software controlling all of your software, you can have one person or many or fewer people supervising thousands of machines. So a lot of what we do would not be possible if not for this. Because you have uniform servers and uniform containers, gives you this mechanism of recovering from failure by moving whatever failed over into the pool of your available resources. This is a so-called one-for-n redundancy, which economically is much less expensive than having to have two sets of equipment and maintaining two sets, or three. I've heard it said, a certain point of view, a very traditional broadcast point of view is if you have one, you have none. If you have two, you have one, and if you have three, now you've got redundancy. That is very well and good, but it's very expensive. Having the ability to move things around gives you the ability to use multiple geographic zones far enough apart that if there is a major disaster, you still stay up. And for instance, this is what Amazon AWS calls their multi-AZ, multi-availability zone. So there's some additional benefits that add why we use virtualized software. Remember I said you use pools of servers. You don't have to rigidly plan those pools of servers. You have some flexibility there. This comes from the standardized container software. You don't have to have those exact machines in that room as your hot spare. It can be any one of the pool, or it can be something that you hire third party. Because these containers are able to be moved, now you have these choices where you can run on premises, you can run from maybe in your city, you have a provider, a server, what you call a private cloud provider. That can come with services that professionally managed. You can use the big guy, Amazon, Google, Azure services, and you can go back and forth between them. Hybrid cloud is often described as a piece of the professionally managed cloud on your premises. That gives you very important economic benefits. Sometimes you have seasonal demand, or an on-demand consumption allows you to use a third-party resource, not to have to build that in your house. Sometimes you may want, the whole goal is to get professionally managed resources on your premises. If that's what you want, you can get that. Or you still can build your own resource in-house if that's what you want to do. Virtualization and containerized software enables the end customer to choose what they need, what they want. So this is just a diagram. This actually was created by, at Telos, Derek Pilkington, our VP of Engineering. And it's just a graphical description of the range of choices that are now available, that are enabled when running your products as virtualized software. And I wanted to point out one additional factor, and that is the speed of light starts to play a part here, and that your time of flight latency can become an issue. For instance, when we do a virtualized audio mixer, and if you're listening to your own mix of your own voice in your headphones, the number that's often used is what, until it starts to sound weird, is around 5 to 7 milliseconds. Well, you can't go to another city and back. The speed of light doesn't allow that in less than 7 milliseconds. So you're into the tens of milliseconds. So it may be that you're doing some of your processing on your premises just to get the lower latency of self-monitoring. Now, on the other hand, we're all used to cell phone calls. Whenever you're talking with someone else, cell phones are typically anywhere from 80 to 100 to 150 milliseconds, depending where they are around the world. So it is possible to have live shows between people through the cloud. So the time of flight latency is not so bad. That feels very natural. We do it all the time, every time we have one of our Zoom calls or a Google Hangout. But that last step of mixing to your own ear can't be remote. Einstein says so. So, I was going to wrap up a little bit with some of the reality, because it's not fair for me to talk about all this magic and not mention some of the reality of the constraints. So I talked about the orchestration software automatically recovering from a failure and getting that function running again on another available server. That automated recovery transition takes some time. A handful of seconds, I'll say. It's not instantaneous. It's not glitch-free. So this raises a really fundamental economic question that you can't avoid answering. And you could say this is the most important question around this whole issue. Can the broadcast or media workflow that you need, that the customer needs, that you're trying to set up, can it be defined as successful if you have rarely a multi-second outage. So we all know what a traditional broadcaster, if you asked them 20 years ago, would say, no, of course not. But the economics, if you can define that to be okay, then you can take advantage of all of this virtualization in this way. So this is a really big question. If not, what do you do? Does that mean you still have to build hardware? Well, no, not really. What it means is, in your operations are going to cost more, you're going to have to spend and consume for redundant end-to-end flows twice or 3 times, depending on your tolerance for what can happen. So it translates exactly now down to dollars, to OpEx. And here's the final point. Even if you do that, even if you're in a situation that you do require essentially glitch-free, redundant, end-to-end production flow, how are you going to keep those up? Hardware still fails. So everything that I've talked about here today is still needed. The high availability automation, the orchestration, the failover to the pool of servers, all of that is still critically essential for keeping both of those redundant paths up. Otherwise, you're going to have somebody getting up in the middle of the night and trying to drive and get that backup up before the primary goes, get the primary back up before the backup goes down or some problem. So keep that in mind. Everything we've talked about is always going to be important and necessary. There's a choice at the end how much you spend on redundancy or not. So that's it. If there's any questions, we've got a few minutes. So if anyone would like a copy of the presentation, Tina will scan the badge and send out. Okay? Thank you.
Thank you very much, Greg.